going to show you how to do single replacement reactions practice and go over what a single replacement reaction is. I'm using Kami to show you things on my screen, but this is also a Google Doc which you can complete just by typing. So, each reaction on this page is a single replacement reaction. The reactants include one element and one compound. A reaction occurs and the single element replaces an element in the compound. The products include one element and one compound in a different combination than the reactants. Let's look at the example. Chlorine is the single element right here, and then magnesium iodide is a compound. So the reaction occurs, the chlorine element replaces the element iodine that was in the compound. Our products include one element, the iodine, and one compound, the magnesium chloride. Notice how it's a different combination than the reactants. Whenever you finish a question, you should look back and make sure that your reactants and your products are different from each other and that you have all the same elements on both sides. Most mistakes that you could make along the way will be noticed if you check those things. In these examples, you're going to fill in the blanks in the products. Each line is one element symbol. All the coefficients and subscripts are done for you. So wherever you see a small line, that's where you need to put the 1-letter or 2-letter symbol of an element. It's the only thing you need to do. Let's try the first example. Zinc is an element. AgNO3 is called silver nitrate. That's a compound. I can tell because there's silver atoms and nitrogen atoms and oxygen atoms. So they're different elements together. That's the compound. Those are going to react to form 3 blank and zinc nitrate. So zinc went into the compound with the nitrate. That means Ag, silver, got kicked out. So that is my other product. So notice how we have one element, one compound in the reactants, one element and one compound in the products. Okay, we're going to try 2 more together. I'm going to scroll down to the 5th one. 2Na plus H2O yields H2 plus blank. Since I see H2 as a product, I see the hydrogen came out of the compound. I know the sodium element will take its place. So the first blank should be Na. Okay, so the sodium element came into the compound. It kicked out the element hydrogen. The oxygen has been there all along and will stay there. Okay, I'm going to show you one final example. It's the one right below this. I wanted to show you that NO3, even though there's 4 different atoms in there, that happens to be what's called a polyatomic ion. It means that those 4 atoms all have a charge on them as one unit, and they all stick together in this reaction. So, lead, Pb, got kicked out of the compound. I see that in the reactants, it's part of the compound, and in the products, it's not. That tells me that Fe, the element that used to be alone, took its place in the compound. And then the NO3 stayed put in the compound. Okay, so each equation has 1 or 2 blanks for you to fill in, just like that. When you're done all your reactions, there's a balancing equations review. I ask that you simply try your best with this. Okay, it is something we worked on previously, but I know it was a difficult skill. So just take a look, follow my lead. Okay, you're going to take any of the reactions up here, copy them and paste them down to be your reaction number 1, your reaction number 2, and your reaction number 3. I use the same example as before. I take each different element that's there, so I have Cl, that's chlorine, Mg, that's magnesium, and I, that's iodine, and list them. Tell me how many atoms are in the reactants. For chlorine, it was 2 in the reactants and 2 in the products. Magnesium, there's 1 in the reactants, there's 1 in the products. Iodine, there's 2 in the reactants, and there's 2 in the products. Okay, remember that a coefficient, the large number in front of an atom or molecule, means that you have that many times whatever's inside. So for example, if I have 2 HCl here, that means that's 2 hydrogens and 2 chlorines. All right, feel free to submit with the balancing equations review incomplete if you're struggling with it. As long as you have your single replacement reactions done, you may submit it, even if you're having trouble with the balancing equations review, because I really am eager to see how well you understand the single replacements. All right, thank you and have a great day.